The 13th question. A symmetric thin biconvex lens is cut into 4 equal parts by two planes AB and CD as shown in the figure. If the power of original lens is 4D, then power of a part of the divided lens is. To see a symmetric thin biconvex lens. This is a thin symmetric biconvex. That means biconvex means what? Those two curvatures remains the same. That means R1 is equal to what? R2 is equal to what? R. So it is a equiconvex lens. Okay, symmetric means what? Equi. Okay, this is cut. Its power is equal to what? 4D. Okay, you know from lens maker's formula, what is 1 by F is equal to what? Mu minus 1 into 1 by R1 minus 1 by R2. Okay, you know power is equal to what? Reciprocal of focal length is called power. Therefore mu minus 1 into, that means what? Mu minus 1 into 1 by R minus 1 by minus R. Why? Because R1 is equal to R2 is equal to R. Okay, which is equal to what? 4D. Okay, which is equal to power. Okay, so what you get? P is equal to what? Mu minus 1 into, what is that? 2 by R. Okay, which is equal to what? 4D. Okay, this is given. Okay, now what happened if the power which is cut into 4 equal parts? Now the same is cut into 4 equal parts. So this is one part, this is another part, this is third part, which is equal to what? Like this, isn't it? This is also further cut. When you cut along this one, along CD, this is half part. Along AB, this is 1, 2, 3, 4. Okay, so which is equal to like this. Okay, so its radius of curvature is R. Its radius of curvature is equal to what? Infinity. It is also same, which is equal to what? Why? Because it is a flat. Okay, okay, straight line. Okay, its radius of curvature equal to infinity. So now new one focal length 1 by F dash is equal to P dash is equal to mu minus 1 into 1 by R1 equal to R minus 1 by infinity. So you get P dash is equal to mu minus 1 into 1 by R, isn't it? But you know which is equal to P by 2? P is equal to mu minus 1 into 2 by R. When it is divided by 2, you get 1 by R. So which is equal to what? 4D by 2. That means what? 2D. So the new piece, that means whether you take this one or you take only this one, any one of them. Okay, having power is equal to what? 2D. Right. The 14th question. A series LCR circuit. A series LCR. L. Inductor. Capacitor. Okay, and a resistor. A series LCR circuit connected to an alternating source of EMF, which is connected to an alternating source of EMF. Its EMF E is equal to E naught sin omega t. Okay, right. The current amplitude at a resonance frequency is I naught. So at resonance condition, what is at resonance condition? XL, that means inductor capacitance is equal to what? XC, capacitor reactance. Okay, inductor reactance is equal to capacitor reactance. Therefore, net resistance R net is equal to what? R square, resistance square, plus XL minus XC whole square. Isn't it? That implies what? R square plus 0, which is equal to what? R. Okay. So what is given? Amplitude of resonant frequency is I naught. That means the current. Therefore, current I naught is equal to what? E naught, maximum EMF by R net. Okay, this is the condition you get. Later what happen? If the value of resistance R becomes twice, if the value of resistance is what? New resistance R is equal to what? To R. Okay, of its initial value. Then amplitude of current Therefore, amplitude of current I0 dash is equal to what? E naught by R dash. This is R dash. That implies I0 dash is equal to what? R is equal to what? 2R. Which is equal to what? I naught by 2. Therefore, current I0 dash is equal to what? I naught by 2. This is the answer for this question. Ready, the 15th question. An electron projected perpendicular to a magnetic field B moves in a circle. To see any charged particle that projected into a uniform magnetic field, what happened? Perpendicular to it revolve in circular path. So the necessary centripetal force is provided by the magnetic force. So what happened? When it is projected, it revolve in circular path. Okay, so the necessary centripetal force is provided by the magnetic force. Okay, right. Fc is equal to what? Centripetal force. The necessary centripetal force is equal to mv square by r is equal to, what is the magnetic force? What is the magnetic force field provided by the force exerted on a charged particle? What is that? BeV. To see, on both sides VV is cancelled. You get mv by r is equal to BE. Okay, that implies mv is equal to what? B into E into R. This is equation 1. Next, what happens? If Bohr's quantization is applicable, according to Bohr's quantization, according to Bohr's quantization principle, quantization, what is that? The angular momentum of revolving electron is integral multiplies of nh by 2 pi. Here L is equal to what? mvr, isn't it? Momentum into perpendicular distance is equal to what? nh by 2 pi. This is equation 2. Okay, now I would like to substitute mv value in this equation 2. Equation 1 sub in equation 2. That implies I replace mv equal to what? BER into r. What is that? BER square is equal to nh by 2 pi. That implies r square. Okay, the radius of the electronic orbit in the first excited. That means, first of all, you can calculate what is the relation between radius and principal quantum number. So r square is equal to what? nh by 2 pi into b into e. That implies r is equal to under root nh by 2 pi b into e. What is asking? What is the radius of the electronic orbit in the first excited state? That means, to see electron revolve around the nucleus, this is called ground state. Higher state, that means other than ground states, are called excited state. First excited state means, that means the electron in the second orbit, that means n is equal to what? 2. That means first excited state, for first excited n is equal to what? 2. Therefore, radius of an electron in the second, that means first excited state, R2 is equal to what? You can replace n by 2. That means 2h by 2 pi b into e. This cancel. Therefore, radius of the second excited state, R2, is equal to what? H by pi into b into e. Okay, this is the answer for this question. Okay, right. Right. The 16th question, a rectangular metallic loop. See, this is a one rectangular metallic loop is moving out of a uniform magnetic field region to a field free region. Now this is with a constant speed. So this is the metallic loop. Okay, is moving. Okay, what happened? With a constant speed from magnetic field region to field free region. Suppose a magnetic field is supposed to be start from here. Okay, what happened? This is the metallic loop is move from field to field free region, okay, with a constant speed. Okay, when the loop is partially inside the metallic field, that means initially this metallic loop is partially inside the magnetic field, the plot of magnitude of induced EMF with the constant with the time is, suppose you can draw a graph between what is that induced EMF, okay, and the time. What is the nature of the graph is asking. You know very well, when any rectangular metallic loop is moving inside a magnetic field, okay, it induces an EMF. This is called this EMF is called motional EMF. So motional EMF developed inside this metallic loop, E induced EMF, E is equal to what? B into L into V. Moreover, here B is a constant. Here given, what is that? Magnitude of the induced EMF with that means here induced EMF. That means in here B is constant. B is what? Constant. Okay. Rectangular loop of a moving out of a uniform magnetic field. B is constant. That implies what? Induced EMF is directly proportional to L into V. Length into velocity is called length into velocity. Okay, is called. Okay, what is length into velocity? Velocity is equal to distance by time. So what is asking? Induced the graph between E and T. You know, partial. Let me actually this rectangular loop is initially only small part inside the magnetic field. So that means initially at the time of it, you can start its motion, it having some induced EMF. Once it is coming out, there is no change in EMF. That means it remains what? Constant. So when you draw a graph between E and T, it is like a straight line parallel to time axis. Parallel to time axis. Okay, that's it. The 17th question. A light source of wavelength lambda illuminates a metal surface. Suppose to say this is a metal surface. This metal surface is illuminated by a light source of wavelength is lambda. Okay, so what happened? Electrons are ejected with a maximum kinetic energy 2 electron volt. Okay, so lambda 1 is equal to lambda. So what is the Kmax of ejected electron? 2 electron volt. If the same surface is illuminated by light source of wavelength lambda by 2. Now what happened? This is the same metal surface now which is allowed to incident or illuminated by a source of wavelength equal to what? Lambda by 2. So what happened? Electrons are ejected. So what is the kinetic energy? So what happened? Kmax is what? Whenever it is illuminated with the same metal plate by a wavelength of lambda by 2. What is the work function? Then the maximum. So work function, okay, W is equal to what? 1 electron volt for same metal plate. So from Einstein's photoelectric equation, Einstein's photoelectric equation, what is that? Hc is equal to what? Work function plus Kmax, or h nu actually Hc by lambda is equal to what? Work function plus Kmax. In this case, Hc by lambda 1 is equal to what? Lambda is equal to what happened? Work function. What is it? 1 plus Kmax 2 electron volt. So you get Hc by lambda is equal to what? 3 electron volt. This is the equation 1. Now the same metal plate is illuminated by a wavelength lambda by 2. Now in this case, what is the kinetic energy of ejected photoelectron? Same, Hc by lambda 2 is equal to what? Work function 1 plus Kmax. This is required, Kmax. Okay, right. But see, which is equal to what? Hc by lambda by 2. Why? Because lambda is equal to lambda by 2 in this case. is equal to what? 1 plus K max. So you can write Hc by lambda, that means 2 into Hc by lambda. You write 2 into Hc by lambda is equal to what? 1 plus K max. From equation 1, Hc by lambda is equal to 3 electron volt. So 2 into 3 electron volt minus 1 is equal to what? K max. 1 electron volt actually here. So 6 minus 1 electron volt is equal to what? K max. Therefore, K max is equal to what? 5 electron volt. This is the solution for this question. At the 18th question, a proton is moving undeflected in a region of crossed electric and magnetic fields at a constant speed, something. Okay. Here, crossed fields means what? Electric and magnetic fields both are mutually perpendicular to each other. Then the electron, that means the charged particle is moving undeviatedly. So, for a constant speed, what is that? E must be equal to what? B. So V is equal to what? E by B. When the electric field is switched off, if E is equal to what? 0. Electric field is what? Switched off. The proton moves along a circular path. So for circular motion, the necessary centripetal force is provided by the magnetic force. You know, for centripetal force equal to what? mv square by r is equal to magnetic force q into v into b. Here q is equal to what? Charge of the proton. That means what? E. So from this 1v is cancelled. Therefore, mv by r is equal to what? B into E. That implies B is equal to mv by E into R. This is equation 1, this is equation 2. From equation 1 and 2, what is asking? What is the electric field? So from 1 and 2, you can write E is equal to what? V into B. That implies E is equal to what? V into mv by E into R, which is equal to what? M into V squared by E into R. Isn't it? So now you should calculate electric field intensity value. Therefore, E is equal to M. Mass of proton is given. What is that? 1.6 into 10 power minus 27 into V. What is the speed of the proton? Square means 4 into 10 power 10 by E. Charge of proton 1.6 into 10 power minus 19 into R. What is the radius of circular path? 2 centimeter means what? 2 into 10 power minus 2. 1.6 cancel 2 1 ja, 2 2 ja. 2 into 10 power 4 Newton per coulomb. Therefore, compare it with E is equal to what? X into 10 power 4 Newton per coulomb. Therefore, X is equal to what? 2. The 19th question, assertion and reason type. What is the assertion? In Young's double slit experiment, the fringes produced by red light are closer as compared to produced by blue light. To see, in Young's double slit experiment, fringe width beta is equal to what? Lambda d by d. Therefore, fringe width is directly proportional to wavelength. You know very well, we know what is that? In spectrum, wavelength of red is greater than wavelength of what kind of light is given? Blue light, B. When lambda is more, for which fringe width is also more, that means beta r, that means fringe width of red is compared to more than fringe width of blue light. But in the assertion, in Young's double slit experiment, the fringes produced by red light are closer. No. Red light are not closer, isn't it? Fringe width is more. Okay, so this is wrong. This is what I say, wrong. Okay, next, what is given? The fringe width directly proportional to the wavelength. Yes, it is correct. It is correct. So assertion is wrong and reason is correct. Okay, but assertion is not exact explanation of the reason. Okay, right, that's it. Right, the 20th question. Two long parallel wires X and Y separated by a distance of 6 centimeter. To see, there are two wires. This is wire X and this is wire Y, separated by a distance of 6 centimeter. Okay, the distance between these two are say 6 centimeter respectively. Okay, carry currents 5 ampere. It is carrying current 5 ampere. It carry current, what is it, 4 ampere respectively in opposite direction as shown in the figure, right? Okay, the magnitude of the resultant magnetic field at a point P at a distance of 4 centimeter from wire Y. So you want to calculate magnetic field at a point P which is distance of what, 4 centimeter from wire Y is something. Okay, the value of X is, okay, to see, according to Ampere's law. Okay, what is that? Magnetic field produced by a straight current carrying conductor at a perpendicular distance, okay, is given by B is equal to mu naught I by 2 pi r. You know, the direction of magnetic field at this point P due to this wire X is into the board, that means into the plane. Okay, so due to magnetic field, the magnetic field is what? Into the field. It is called produces B1. Due to Y, the magnetic field at this point P is coming out from the point, out of the board. It is called B2. So net magnetic field at point B. Net field at point P. At point P is B is equal to what? B1 minus B2. Because both are acting in opposite direction. Because B1 is a vector, B2 is also a vector. Okay, therefore net field B is equal to what? B1 is equal to what? Mu naught into I1 by 2 pi r1 minus mu naught into I2 by 2 pi r2. From this one I would like to take mu naught by 2 pi as common, I1 by r1 minus I2 by r2. Therefore B is equal to, mu naught is already given, what is it? 4 pi into 10 power minus 7 by 2 pi into I1. What is the current in the first wire? X, 5 by R1. What is the distance of this wire from point P? 6 plus 4, 1 centimeter means what? 0.1 meter minus I2 is equal to what? 4 by this wire is at a distance of 4, that means what? 0.04, isn't it? 0.04. So when you calculate it, 2, therefore B is equal to 2 into 10 power minus 7. When you take this as a 0.04 is a LCM, 0.4, that means we get its value is equal to what? 2 minus 4, isn't it? Therefore B is equal to minus 2, means minus 4 by 0.04 into 10 power minus 7. That implies B is equal to minus, what is it? 10 power minus 2, 10 square, 4, 1 by 100 means 10 square. When it is go to the numerator, 10 square into 10 power minus 7. Therefore B is equal to what? 1 into 10 power minus 5 Tesla. So according to given equation, in place of X, what is there? 1 is there. Therefore X is equal to what? 1. That's it. The 21st question. A transparent film of refractive index 2.0 is coated on a glass slab of refractive index 1.45. For example, to see, this is a glass slab whose refractive index is 1.45. Okay, on it a transparent film of refractive index is supposed to be coated on its surface. A transparent film of refractive index, okay, what is that, mu is equal to 2, is supposed to be coated. Okay, then what is the minimum thickness of transparent film? What is the minimum thickness of this transparent film to be coated for the maximum transmission of green light of wavelength? Suppose a light of wavelength, how much lambda is supposed to be incident? What happened when light is traveling from one medium to another medium? What happened? From deviate from its actual path, it is bent towards the normal. Okay, reflected back by follow the laws of transmission, laws of reflection. So what happened when light is traveling from denser to rarer? It move away from the normal while draw the normal at this point. So what happened? One more thing I would like to mention. This is a transparent film make maximum, okay, transmit the green light. Okay, you know very well the transmission of a green light, that means reflected green light or whatever may be the color, is always directly proportional to its wavelength. That means, what is meaning? For transmission, what is the for transmission? That means this is the transmission, this is the reflection. Okay, for transmission, what kind of light is given? Green light. For transmission, green light, what happened? It becomes to be maximum. To be maximum, when it is happen, what happened? Reflection of green should be minimum. Reflection of green should be what? Minimum. Isn't it correct? Reflection of green light should be minimum. Isn't it not? For transmission of light to be maximum, transmission of light should be maximum, reflection should be minimum. Okay, so the difference, that means delta P is equal to 2 into mu naught into, there is a direct formula is there for this one, right? Delta P is equal to 2 into mu naught into T. Okay, but here he is asking what is the minimum thickness? T is asking. Therefore, thickness of the glass slab, T is equal to what? Thickness of, what is that? Transparent film. Transparent film. T is equal to what? Delta P by 2 into mu naught. But you know, delta P is directly depends on wavelength, isn't it? N is the number of coated films. Therefore, T is equal to what? N into lambda by 2 into mu naught, equal to what? 1 into lambda. What is the wavelength incident? Okay, on this wavelength, what? 550 nanometer. 550 by 2 into mu naught. What is the mu naught? This is what I say, mu, this is the mu naught into 2. Okay, so 550 by 4. So you get 137.5. What is it? 137.5 nanometer is also nanometer, so it is a nanometer. Why? Because lambda is in nanometer, mu naught is doesn't have any unit, so that answer must be in nanometer. That's it. You know, the 22nd question. The current flowing in the given circuit is dash ampere. This is the question is asking. This is the circuit. To see here, there is a battery 2 volt. There are resistors, but one capacitor is there. You know, a tricky question asked in this question in this exam. You know, capacitor. You know very well, capacitor is allow only AC current, isn't it? It is black DC. Capacitor allows only AC, only allow AC current. It blocks DC current, so that there is no chance for flow of current through this one, through this one, through this one, through this one. Similarly, this one is also not possible. So rearrange this circuit. Battery is same, isn't it? Next, this 2 is there, okay, and this 4 is there, this 3 also there, and this is also there, 6. This is 2, this is 4, this is 3, this is 6. That's it. You know, these two are in parallel. These two are in what? Parallel. So again redraw the circuit. This is 2 ohm. This is what? 4 ohm. Okay. Instead of these three, these two are in parallel. So 1 Rp is equal to what? 3 into R by 3 plus 6. 18 by 9 is equal to 2. So instead of these two, you can write 2 ohm. Isn't it? Right. Now this is 2, this is 2. Okay. Now these two are in series because same current is flow through this one and through this one, but different current is flow through this one. So these two are in. That implies again this is rearrange. This is what? 2 volt. This is what? 2 volt. Again rearrange this equation, circuit diagram. Okay. What is that? Here there is 2. There is a 4, isn't it? Yes, 4 ohm. Instead of these two are in series. That means these, instead of this one, you can draw a circuit like this. This is equal to what? 4. Okay. Why? Because here 2 plus 2 Rs is equal to 4. Again these 4 in parallel. This is what? 2. Therefore Rp is equal to what? 4 into 4 by 4 plus 4. 16 by 8. 8 1 ja, 8 2 ja. So the net current, net resistance in this circuit is equal to what? 2. Therefore current I is equal to what? V by R. V is equal to what? 2 by resistance equal to what? 2. Therefore I is equal to what? 1 amp. So the current is what? 1 ampere in this circuit. Right. The 23rd question, a parallel plate capacitor of area 16 centimeter square and separation between the plates is 10 centimeter. To see, this is a parallel plate capacitor. There are two plates, okay, whose cross section area A is equal to what? 16 centimeter square, and these two are separated by a distance of D is equal to what? 10 centimeter. Is charged by a DC current which is connected to a DC source. Okay, right. Consider a hypothetical plane surface of area A0 is equal to. Hypothetical plane surface of area 3.2 centimeter square inside the capacitor plates. Okay, and parallel to the plates. Okay, right. At an instant, the current through the circuit is equal to what? 6 ampere. At the same instant, the displacement current through A0 is, this is A, this is A. You know, the displacement current JD is equal to what? Current per area. Displacement current equal to what? What is that? Current per area. Okay, so JD displacement current value is equal to what? Current I by A. Initially, what is the current is passing? 6 ampere. Cross section area is equal to what? 16. Isn't it? So this is the value. Now the displacement current, that means now what is asking? The same instant the displacement through A0 is. Now the displacement current through A0 is I0 is equal to what? JD into A. Isn't it? JD into A. Therefore I0 is equal to, JD is what is given? 6 by 16 into, what is the cross section area of this hypothetical Okay, hypothetical plane surface area is equal to what? 3.2 into 3.2, isn't it? So what happened? 0.2 is equal to what? 12. Okay, what is that? 12. Okay, but asking in milli, that means what? 12,000 milliampere. So answer is what? 12,000 milliampere. Sorry, 12, not 12,000, not 1200. 1200. Okay, ampere. Right. The 24th question. For a short dipole placed at origin O, okay, the dipole momentum P is along x-axis, along the x-axis. This is the dipole momentum P. Okay, as shown in the figure. If the electric potential and electric field at A, at point A, that means along the x-axis. So, electric field on x-axis, it is nothing but EA is equal to what? 2 kp by r cube. Okay, for a short, already this given in the question, short dipole, EA is equal to 2 kp by r cube, which is given in this question. It is says as E naught. Okay, electric potential, next one is called electric potential on same x-axis, it is called VA. You know very well, electric potential is equal to what? Field per distance, isn't it? So you get 2 kp by r square. It is says as V naught in the given itself, in the question itself, V naught and E naught respectively. Then the correct combination of the electric potential and field respectively at point B on the y-axis, at point B. These two are at point A on the x-axis. Now at point B is lies on the equatorial line at B. What is it? Electric field on y-axis at a distance equal to what? 2r is, what is that? What is that? EB is equal to, that means point B, capital B, EB is equal to what? kp by r cube, but r is equal to what? 2r, therefore kp by 2r whole cube. It will write kp by 8 into r cube. So it writes 1 by 8 into kp by r cube. So which is written as by 2, that means 1 by 8 into 1 by 2, which is EA 1 by 8 into EA by EA means what? E naught by 2. Why? Because kp by r cube by 2 is equal to what? You get the value. So that E naught by 16 is the electric field. Next, potential at point B. You know, while we are going along the y-axis, potential remains the same. So it is an equipotential surface. So that VB is equal to what? 0. So correct combination is electric field at point B, comma potential at point B on equatorial line is equal to what? E naught by 16, comma 0. This is the answer for this question. Okay, right.